Добрый день, уважаемые участники конференции. Мой доклад сегодняшний
Hello, dear conference participants. My report today is the transmission current mechanisms and photovoltaic properties of solar cells based on the p-cadmium and cadmium-S structures with deep imputability levels. In this paper, the mechanisms of transmission current and photovoltaic properties of solar cells made on the basis of strongly mismatched semiconductor structures with a low density of surface states of 10 power -11 square centimeters are considered. It has been established what is heterojunctions. The forward current is caused by tunneling of thermally excited electrons, and at large forward displacement, the current has a thermionic character. The reverse current of such structures has a tunnel nature. It is shown that the structures have a phototransmission affinity of the 0.7–0.8 electron volts per quantum in the spectral range of the 0.4–0.3 electron volts in the near-infrared region of the spectrum. Cadmium-S and cadmium-tellurium heterostructures of good quality have been obtained using traditional technological methods of height vacuum, although their crystal structures are different, hexagonal and cubic for cadmium-S and cadmium-tellurium respectively, as well as a large mismatch of lattice constants and the thermal expansion coefficients. The combined effect of these factors leads to a high density of surface states N at the interface, which sharply worsens the characteristics of heterostructures, and this can be eliminated using the optimal production technology. The magnitude of the surface state in the cadmium-tellurium-cadmium-S structure can be significantly reduced by using elements of group first for their preparation. The structure had pronounced zero characteristics with a rectification coefficients of at least 10 power 4 at 300 kelvins and a voltage of 1 volt. The thickness of the transmission and the displacement found from comparative measurement depends on the temperature and duration of annealing and is within 2 microns. The value of D has a relatively weak effect on the spectral distribution of photosensitivity, but it significantly determines the mechanics of current passage as well as the absolute values of the photocurrent and EMF. The studied structures were conjecturally divided into 3 types: A, 0.3, 0.5, B, 0.5, 0.1, and C, 0.1 microns. The volt-farad characteristics have a different appearance depending on the type of structure boundaries shown in the first figure. The capacity of the structures under study depends on the frequency at which the measurements are performed. As follows from the figure, as the frequency increases, the slope of the straight lines increases, and the cutoff voltage entirely decreases and then becomes constant and equal to 1.1 volts. At the higher frequency of 1 megahertz, the capacitive dissipation is associated with the presence of different combination centers in a charged state in the region close to the heterostructure. Thus, the technology used makes it possible to obtain heterostructures with a small number of defects at the interface, even for semiconductors with very different structure, lattice constant and thermal expansion coefficients. Such a small surface state has practically no effect on the photosensitivity of the studied structures, but it significantly affects the mechanisms of the current passage. Of course, as the thickness increases, the probability of tunneling decreases for both holes and electrons. As a result, at low forward displacement, a combination possessed in the space-change region becomes dominant, which is shown in the following figure. The forward current is described by the expression. As follows from the fourth figure, up to three sections, this different exponent can be distributed based on the current voltage dependencies. At the smallest displacement, up to certain voltage, ohms law is fulfilled. At no load voltage, this dependence changes quantity, and when the voltage is greater than no load, the traps and compatibility field. When comparing experimental data with theoretical expansions, it's possible to determine some parameters of the quasi-insulation layer, Kerr concentration, and lever position. Fermi level concentration and depth of traps, the results of such calculation are shown in this table. The studied heterostructures were photosensitivity, and the shape of the spectrum is almost the same for all types of diodes, which is shown in the fifth figure. The low energy age of the spectrum is determined by the generation of photon carriers in the layer. The smallest band gap EI is 1.3 electron volts. The sharp decrease in the photoactivity in the range of photon energies of 2.4 electron volts is due to their absorption in the thickness of the cadmium S crystal. As the temperature decreases, the spectral characteristics shift to the short one-light region, and the shape of the spectrum remains almost unchanged in the temperature range of 100–360 kelvins under study. The magnitude of the temperature shift of the long wave and short wave age of the spectral dependence is 4.4 power the 10 in the power of the -4 and 5.2 in the power of 10 power in the -4 electron volts per Kelvin, which is close to the temperature coefficient of the characteristics in the band gap of the solution of cadmium S and tellurium. As can be seen from the figure 5, the photosensitivity spectra shifts of 4 to the long wavelength region of the spectrum, and this indicates that there are deep levels in the cadmium tellurium responsible for imputability photoconductivity. By analyzing the absorption spectra, deep levels of activation energy were determined, which are equal as shown in figure 6. Studies have shown that in all heterostructure short-circuit photocurrents as well as photocurrents is a diode mode linearly depend on illumination over a wide range its variation. As the intensity of the incident light increases, as the inline voltage tends of saturation. However, the absolute values of the short-circuit current and the no-load voltage depend significantly on the type of structure. They are maximal for heterostructures and amount to the 20 milliamperes per square centimeters and 0.6 volts under voltage conditions. The decrease in the samples is due to an increase in the dark current compared to the photocurrent. An increase in the thickness of the high resistance varioso layer and leads to the increase in the series resistance limiting the short-circuit current. The efficiency of all types of structures is approximately the same, and without the used anti-reflective coating in the is 0.7–0.8 elements per quantum. This is confirmed by perfection of the interface and the weak influence of detection photovoltaic properties. As shown in the figure 6, the spectral dependence for short current or on the light energy at different temperatures. The activation energy of deep imputability level located below the conductivity band by 1.35 and 1.1117 and the 1.29 electron volts respectively are determined by the spectra. Consequently, this increase in temperature, the thermal generation of change carriers also increases, and as a result, the effect of additional illumination on the short-circuit current spectra decreases. For the cadmium-tellurium-cadmium acetate structure, the dominant level is 1.35 electronvolts, which suggested what this level is associated with silver or its complex with other point defects. In conclusion, it can be said what high photosensitivity combined with a wide range of linearly and relatively high response speed make it possible to use the studied heterostructures as photodetectors in the spectral range of the 1.3 to 2.3 electronvolts due to the prevalence of deep invisibility levels. Note that it covers the radiation area of most industrial leads on the A3B5 connections. In addition, these photodiodes are spectrally consistent with the elimination of essentially developed scintillations based on the A2B6 single crystals. Solar cells based on the cadmium S and cadmium tellurium heterostructure have an efficiency of 22% with a temperature coefficient of 2.5 power to the 10 in the power of the minus 2% degree, with about 4 times less than when that of silicon diodes. Thank you for attention.
Примерно 4 раза меньше, чем у кремниевых диодов. Спасибо за внимание.